with no further ado, let's kind of begin our feature presentation. Next-gen data pipelines are virtual. Simplified data pipelines with dbt, Dremio, and Iceberg. Again, the big theme here, okay, and I will be your presenter today, is about how difficult things are and how easy they can be. Okay, and we're going to paint that picture for you. First, let's just talk about sort of how things are. So right now, you generally have your data sources through a complex layers of data pipelines. You land that data in the data lake. And again, it's not just generally single pipelines. You might have chains of pipelines because basically one data movement or one data transformation is dependent on another. So you end up having this large sort of layers of changes. But then still a lot of your data ends up ending up in the data warehouse for a variety of reasons, for many different use cases. So you have an additional number of layers of pipelines. And again, that means more code you have to write, test, deploy. That means there's more costs in compute. That means there is, so it's, you're using up time, you're spending money, and you're creating duplicates of your data. Okay, all the service, all the data for your clients. Okay, so this can get really expensive and, you know, it can be better. Okay, so what's the problem? Okay, problem is when you have more and more pipelines, all these layers of pipelines are more likely to break, and that's going to require tedious backfilling, you know, having to figure out what the error is, edit that code, retest it, redeploy it. It can get really tedious and really set huge delays in getting the data to the people that need it. So then people end up getting data that's late or that's inconsistent because those problems weren't caught. And well, again, that just leads to bad insights. So on top of just sort of the lack of value you get and the time that's lost and the lack of quality of data that may occur from too many complex data movements, you have the storage costs, you have the compute processing costs, you have the network and egress costs as you move data across different regions, lost productivity and all that time that is wasted, regulatory fees when you have PII that should have been that should not be there or is visible to the wrong people. Data model drift, when you have too many copies of data, things move away from where the original data model was, and the cost of those bad insights. What if you make bad decisions that actually have negative impacts to company value because you were looking at the data wrong? Okay, so Dremio tries to simplify this because the idea is if you have less pipelines, if you move the data less, you can curate the data faster and also have less costs. So Dremio brings you this sort of, again, shift left paradigm where essentially we're going to focus everything more on the data lakehouse. So focusing on operationalizing your data lake. And then your long tail of other data sources, which may be sort of, you know, some databases here and there, but connect all that data to Dremio. So again, generally you would just land your data in a table format in your data lake. Okay, Iceberg, Delta Lake can both be read by Dremio. You land that there, you connect Dremio, and then you're able to kind of serve that data efficiently to your use cases without the additional movement into a data warehouse and just deliver it directly to your clients. And you get the benefit from that federated data. So you can connect data sources directly to Dremio, such as databases. So some data you may not want to move directly into your data lake, or you may be getting it from like third-party share using third-party sources of data that you can't move. You can connect those sources directly to Dremio. So that gives you some more zero, low ETL vibes. You get the curated semantic layer, so that allows you to govern that data, control access to that data, do column and row masking on that data. So that way, when whoever has access to particular views of that data will only see the data they should have access to. And again, none of this requires you to do any additional movements or additional copies of the data. And then basically, in order to optimize performance where optimizations may be needed, there's Dremio's data reflections. And oftentimes figuring out when you need these is much easier than ever because Dremio now has a reflection recommender that'll help identify you know, query patterns that could use a reflection of what the specific reflection needed is. Okay, creating a very powerful ability to kind of manage your data lakehouse because, again, you don't have to move data much. And when there are bottlenecks, Dremio's going to help you identify those bottlenecks and recommend you solutions to fix them. So again, benefits of this Dremio approach, again, less pipelines, less backfilling, fresher data sooner. Okay, your data consumers are going to be much happier because you're getting that fresh data faster. It's going to be correct because you're going to have much more room to test and validate that data because you're, again, less movements. And then again, you're going to also save the company money. Okay, less copies, less storage costs, less pipelines, less compute, less data movement, less network costs, Again, less movement, the pipelines are more likely to remain fresh. You're going to have less copies of the data in one place. Overall, you're just going to have a better story. And if you want to see a really good example of this, a couple episodes ago, Standard & Poor's discussed implementing a data lakehouse in their practice. And basically, they saw all these benefits: lower costs, easier ability to deliver the data. Overall, it was a lot of positive. And again, you can hear it straight from them by going a few episodes back in here. Actually, the previous episode to this one. Cool. So again, so far, now we're going to start getting into showing you sort of how some of these things kind of work. But again, nothing beats getting hands-on. So if you scan this QR code here, this will walk you through a tutorial where you'll actually deploy Dremio right from your laptop using Docker and actually see a lakehouse firsthand, create your own object storage with Minio, and just kind of see the experience firsthand. But again, if you want to get started with Dremio, you can always scan this QR code here, which will take you to our Get Started page. So you can actually do a production deployment, whether it's through Kubernetes using K8s or through Dremio Cloud and have a cloud managed deployment. So with that, first thing I'd like to demonstrate is the benefits of Dremio's integrated catalog, which is part of its Lakehouse management features, which allow you to do branching and merging. Okay, so this is going to allow you to be able to isolate ingestion, allow you to kind of give space where you can do validation of data before you publish it, allow you to roll back your catalog when disasters happen, and lots more. So with that, let's queue it up, and I'll see you right after this demonstration. Okay, so what I'd like to show you now is just sort of the epitome of our data lakehouse management features, how powerful the Dremio catalog is. Because not only does it offer you automatic table optimization, automatic table cleanup, so that way you just set it and forget it, and your tables are just going to work and be fast and be nice and crisp. But also you're going to get Git-like semantics powered by the open source project Nessie, allowing you to do branching, merging, tagging of your of basically changes in your data catalog, which is going to enable you to isolate ingestion work, allow you to create zero copy cloned environments, allow you to easily roll back when there is a disaster, basically make your life a lot easier. Okay, so we're going to walk through this query right here, but first let's actually get it running. Okay, so just to give you an idea here, so notice I have these single sort of table names. Well, I actually want it to be run from this particular folder right over here. So I'm going to go open that folder up in my catalog, February, Get Started GW. Now what I would have to do normally is I'd have to drag this over, which is still pretty convenient. Okay, and then I would get that whole fully qualified name there. But I don't want to do that. It's just a lot of typing, and then, I'd rather make it simpler and keep it like this. So how can I do that? Well, there's actually an option right here in the SQL editor that's going to allow me to set the context for the query. So I can say, hey, I want this to be done in this folder. Okay, and now I can go hit run on the query, and then every query will be run in the context of that folder. So it's assuming that fully qualified path before the name of the particular table that I'm working with. Okay, which is super convenient. Okay, and keep in mind, notice I am running multiple queries in the same window, and how convenient that is that I don't have to just run a query, wait for it to run, then do another query and type it out and type it out. I can put them all in the same window, and I can also create multiple tabs to work on multiple sets of queries at the same time. Okay, and then I can always save those as scripts or views, giving a really, really robust, easy to use SQL editing experience in the Dremio user interface. Okay, I'll click run, so this way this begins running. But again, it's not just the Dremio interface that you can do work from. Dremio has several different ways you can connect to the data, whether it's JDBC, ODBC, Apache Arrow Flight, Dremio's REST API, so that way you can always connect to Dremio to have access to all your data for whatever that use case is. Okay, so this is going to be just about wrapping up. So again, basically what we're doing in this query is we're creating two tables. So I've created two tables. So these first two queries create a table and a staging table. The idea is that I want to ingest new data that's going to be in that staging table, but I don't want the data in that staging table exposed to my data consumers. Okay, so what I'm going to do is I'm going to create a branch. Okay, well, first we're going to insert some data into that staging table so that we can ingest it. But then I'm going to create a branch. Okay, so right here I see that I created a branch successfully. And then I'm going to switch over to that branch so that way any future transactions occur in that branch, which means those changes are not going to be visible to queries that query the main production branch. So that means all these changes that I'm doing to my data are not visible by people who are sending in their normal day-to-day queries, which means any data that isn't validated or isn't clean isn't going to be exposed to them. So you're not worried about sending them inconsistent data. Okay. So now that I've done that, I can now run my merge into statement, which is query number 6. So that's this query right here. So notice as I click on the query tab, it actually highlights the query in the text. So that way I know exactly which query that represents. Okay. There's just all these nice little quality of life touches. Okay. So I can see that the merge into statement was successful. It merged in 3 records. Okay. And which either meant it inserted a record or updated a record. So then after that, we're going to run some validation. So first, we're trying to see if we have any negative sales counts. Okay, in this case, we do have one. We're going to check if any of the sales have incorrect dates, which means they have like dates in the future that wouldn't make sense. Okay, there was none that had that, fortunately. So let's assume that we made all of our validation checks and all of that was successful. If I didn't pass my validation checks at this point, I would go back and clean up my data and do what I need to remediate that data. But assuming it's successful, then what I can do is do a merge. But before we merge, I want to show you that the data isn't available on the main branch. So this first query, query 9, is a query on the main branch. And you see that the table is empty because we haven't integrated the new data yet. But if I click on query 10, that's querying the branch. I see the 3 records here. So you see I'm querying the same table. The only difference is I'm doing it on a different branch. Okay. Then if I go to query 11, what I'm going to do is I'm going to go back to my main branch and I'm going to go run a merge statement, merging the commits from the branch we've been working off of back into the main branch. Okay, and now when I query both tables, where I query it from the main branch or the branch that we created, the data is the same because we pulled over those commits. So I've now published my data. So the point is, it's much easier to do sort of a write audit publish pattern. You can almost call it a branch audit merge pattern, or BAM, and basically do your ingestion work much more easily. And again, this is all powered by the Dremio catalog, which is powered by Project Nessie, which means it's not just Dremio that gets this advantage. Any tool that can connect to a Nessie catalog can connect to your Dremio catalog. So you can take advantage of this merging and branching in Apache Spark, in Apache Flink, and other tools that support Nessie catalogs. So basically, wherever you're doing your ingestion work, you can take advantage of this and then still be able to see all those branches here in Dremio. So like over here, when I take a look at this demos catalog, I can see all the branches I created, and I can go browse the data based on the particular branch and the particular commit to actually see the data as it was in the past. And Dremio provides a really nice UI for auditing your catalog. So if I go here to my Arctic catalog, that's these Dremio catalogs. Okay, I can go to any particular catalog, so in this case, demos, and I can go to a particular branch. So I'll go, hey, I want to go take a look at this is the branch we just created. Okay, but let's say I want to go to the data here, and I want to take a look at the data at a particular branch. I can choose which branch I want to take a look at the data as of. So I would just choose this branch right here, and now I'm browsing the catalog as it was on that branch. I can see what commits have been made, so I can see, hey, I want to see the commits on this branch because I switched over to that branch. And I can see those commits. I can see who made the commit. I can get the commit ID, so that way I can roll back to those previous commits. So I get this nice UI that gives me visibility and observability into what's going on in my data catalog. So that, well, is pretty cool. So now I have that observability from the Dremio catalog level, which allows me to know who made changes. And then again, I have the individual transactions that you get from a Apache Iceberg table history that gives you some other levels of sort of flexibility into those tables. So overall, very, very cool. So that's a bit of a tour of the Dremio Cloud Lakehouse platform. It's very robust. There's so much more you can do. But the best way to kind of see all of that in action is to get hands-on with it. So whether it's through a Docker container, through Kubernetes, or creating a Dremio Cloud account, I recommend that you get hands-on with Dremio and try it out for yourself and apply it to one of your use cases with data that you like to work with and see it in action. And I assure you, you will like what you find. Now, the next demonstration I'd like to talk about is our semantic layer. So with the semantic layer, what you can do is you can curate virtual data marts. So instead of copying all this data into a data warehouse and creating more copies of the data within disparate data marts for your different business lines, you could do all that modeling directly on the data lake. So you can create your Snowflake schemas and your star schemas in the same way you would in the data warehouse, but on your data lake using Dremio's semantic layer. This could also be used to to execute, medallion architectures, to execute data mesh. So whatever architectural patterns you want to follow, you can do so in an easy, accessible way that's going to be self-service for your end users and also easy to govern. So let's take a look at how that works. Now, when you're looking at the Dremio UI, a cool thing you can do is when you create these queries that you plan on maybe running multiple times, is you can save them as a view. So I can actually have two choices. I can save them as a script that I can run again. So you can see here, I have many different demo scripts that I have here saved for being able to conduct demos on the fly. But I also can save this as a view so it can show up like a data set. Okay, and this can allow us to construct a robust semantic layer. And just to show you an example, let's pretend that right here I have a tax collections data product in a sense. Okay, so the idea here is here's where we're going to put all our tax collections data, and we're going to do a medallion type architecture where we have our raw data in bronze. So if I go and you see the purple icons, this means it's a physical data set. So these are the actual physical Iceberg tables with the actual data. Okay, so now if I go and I query one of these tables, okay, I see there's a few records, and I notice that there's a null there. Okay, so there's some cleanup work that I need to do because this is the raw data. But now if I go back, what happened was in there, in my silver folder, I did this cleanup. And notice these are green icons, which means these are views. So these are not copies of the data. These are just basically logical SQL views on the data that I created. And I'll show you the SQL in a moment. Okay. But then if I run this, I'm going to notice that I had taken care of these nulls here, and see like the nulls are gone. Okay. But then as another sort of layer of changes, I wanted to join the two data sets I had in there. So if I go back to my tax collections data, again in silver, I have business taxes and individual taxes, and I wanted to create a single view of all the tax data. So in our gold folder, I aggregated both tables. So now we just have all the tax records that have already been cleaned up because they're a join of the silver quality records. Okay, so basically no nulls, all the nulls have been cleaned up, and now I have a unified view, but none of this created a copy of the data. These are all logical views. Okay, so I'm creating layers of logical views without duplicating the data, without increasing sort of my file storage footprint. Okay, and then again, if this was like a really large data set and I wanted to create a BI dashboard off of it, I can always enable reflections to get that sub-second performance on a BI dashboard. But just to kind of show you the SQL behind this, okay, and again, just makes crafting sort of a very easy to see approach, is if I go to the SQL editor, I have it saved as a script. So again, the beauty of scripts, I can easily search my scripts. I can just type in demo, semantic layer. Okay, I can see here that I entered the data. Okay, but then all I have to do is I created a view. I cleaned up the nulls using a couple of the SQL functions available here on Dremio, and then I created the union view or the view in the gold folder right afterwards. And again, I can curate sort of our data model very easily using SQL. Okay, and the cool thing is that none of this is accessible to an average user. So you make a new user account, they don't see any of this. They don't see any of the sources. They don't see any of the sets. If I want a particular user to be able to see the tax collections product, okay, I'd have to go over here, okay, and I'd have to give them access. Okay, and what I would do is I would use SQL to be able to grant access to individual data sets, to individual objects in my storage. Okay, so I can go over here as an example, okay, and I can change the settings, and then from the settings we can then handle privileges and give users with specific roles or specific users access to this data set. And then we also have the ability to do a row and column based rules using user defined functions. So you can easily basically allow users to see the data but not see the data they shouldn't be seeing, and mask certain rows and columns based on rules that you create. Okay, so you can create a robust, secure semantic layer to access your data across all your sources. So I can curate data across all my sources here and make it easily visible and easily organized. And not only am I able to kind of create the visual organization, but I'm also able to create documentation. So for example, if I go over here to the gold folder, okay, and I go to that tax record set here, let's say I want to create documentation. Okay, right here is where you can create the wiki. Here in the details tab, you see this little pen. I can add some labels, but actually what I want to do is I want to edit the wiki. So I'm going to go over to the detail section. Okay, and I can see that there's a wiki entry for this particular data set. I can actually generate the wiki using Dremio's generative AI features. So right now what it's doing is actually reading the data set, reading its schema, reading the data to generate something informative about the information in this particular data set. And once it's done generating, I can literally just copy this over. So I can just literally click the copy button, paste it right over, save it, and now other users who are looking at this data set can get at least a cursory idea, a starting place for documentation on how the data set's set up that they can look at. And the thing is that, orchestrating that semantic layer doesn't have to all be done directly in the Dremio UI. You can actually do it pretty easily using tools that you're probably already familiar with, like dbt. So with dbt, you can run queries in Dremio to create data sets using the DML that Dremio supports on Iceberg tables, or to create views on your data sets and be able to take advantage of the benefits of using dbt, such as being able to have Git version control because it's all written as code, and being able to have just sort of that sort of declarative way of describing sort of your modeling at your disposal, working with Dremio with all the other benefits that Dremio gives you as part of its Lakehouse platform. So let's do a little quick demonstration of that. Okay, we're going to ignore that one because I already created one called test run. And I'll show you what's kind of going on there. This one's already all configured and all set up. Okay, so the main thing you really need here is just really your models. Okay, pretty much you can, for the most part, unless you want to get more advanced with dbt, you can operate pretty much straight out of here in this models folder. Okay, and essentially what's going to happen here is you're going to have several different SQL files, and you can create more. Okay, so by default you'll have like my first dbt SQL file and my second dbt SQL file. And the way each of these work is that they are going to have some bit of SQL in there. Okay, so you'll see. And then what it's going to do is that when we run dbt, it's going to run that SQL, and the output of that SQL command will be created as a view in Dremio. So if I go back to Dremio for a moment, you'll see here, if I go to the dbt practice, January 9 to 2024, you'll see here that the output of the my first dbt model one came out there. Again, it's just like the number one. So that's just going to come out right there. Okay. Oh, back over here. dbt, January 9th, my first model. Run that again. And you see just that's just the one column, one row with the number one. Okay. And then this one, same thing. It's just going to create another view called my second dbt model, because that's what I named the SQL file. But see, this one has that reference. Okay, so you see it's referring to the previous model. So in this case, this knows it should not run until that other model has been run first. Okay, so theoretically here, see, I have like my third model, which refers to this weather. Okay, with this weather data. So for example, I can go here. If I go to my dbt practice folder, I'll have some weather data in here. So let's just run a query on that data first, just to show you. Actually, let me just close all these tabs. Okay, and actually it's just quicker this way. Weather. Now if I run right here in the weather data, you'll see this weather data that's going to show up. And now when I run that third model, it's essentially just creating another view of the same exact data. But let me create another view that depends on that one. Okay, and that one, we're just going to want the date and the precipitation. That's it. So what I'm going to do is I'm going to create in a new file. So we'll call this my fourth model .sql. And essentially we only want to select, and again, the two things we want to select are date and precipitation, PRCP. So date, PRCP from, but I don't want it from the weather data per se. So again, in my third model, I did reference, and see, I can reference anything in my Dremio account. So I was able to just reference that weather data set and say, hey, I just want this view just to be a select all from that data set. And you saw it was created. But now I'm going to do with this fourth model, I'm going to say, hey, I want to do that to reference. And I want to reference my third model. Okay, because that's what we called it there. Okay, and again, just to compare syntax, ref my third model, I see that I use single quotes, so I'll just, to be safe, I will use single quotes as well. Okay, ref my single model. Okay, and then that'll be what that model comes out to. Now just doing a quick double check on everything. Okay, otherwise all looks good. But the idea is that I would create all my models, and then in the future, well, first let's run it. So let's see here, let's do dbt run. So I would just do dbt run. Okay, I'm actually do that in the right folder. So right here in the test run folder. I would do dbt run, it's going to run all the models that are in the folder. So right now it's going to go detect all the models. Okay. So it's going to take a moment to run that. Okay, just a clarification. I made a quick typo. I forgot. I should, since date is a reserved word, I should have put double quotes around it. So I'm going to go run that again. So here we go. Let's try that again. dbt run. Okay, awesome. And now I ran that successfully. And if I can see that it detected the 4 models. It ran each model, and it's going to create the right output. So now if I go back to Dremio, I should be able to go back to my data view, go back to dbt practice, go back to January 9, 2024 here, and see there's my 4th model. And my 4th model should only have those 2 fields, date and precipitation. Okay, so then there, yep, it only has date and precipitation. So how cool is that? Okay, so now what happens if in the future, like I have a data consumer who is using this view and they're like, you know what, I need another column, Alex. Okay, what I could really use is another one of those columns. So let's choose one of these other columns in the weather data. Okay, let's choose snow. So maybe they want that snow column. Okay, what we can do, all we have to do now is head back to our dbt models. I can just add snow. Okay, so simple as that to fulfill this data request, to just add a column that wasn't there before. Okay, and then again, I know if this particular, and by reading this query, I know that this refers to a different model, so I can go check to make sure that the snow column is available in that model, making it easier for me to kind of catch where I need to make these changes. And again, all of this is I can version control with Git because it's code, and then I can just run that dbt model again. Okay, and it can add that column. Okay, so see now that has ran again successfully. So now all I have to do is head back. Let's go back to our Data Explorer. Let's go back to dbt practice, January 29th. And let's see here, does my 4th model, does it now have, the extra snow column? Okay, and it does. Okay, so it becomes easy as that. So I'm the data consumer, and I'm just like, hey, cool. The column was added to the view that I've been working with. And as a data engineer, all you have to do is just add one word and one column. And again, everything becomes easily trackable because you can track it through code version control. And last but not least, again, there's all sorts of different ways for you to do sort of data quality management. Again, you could take advantage of some of the tests that are in dbt. You could use libraries like Great Expectations. You could also just use the Dremio platform to create things like constraint tables that will allow you to kind of create your business logic so you can test your tables against. And we'll do a quick demonstration of how something like that would look in managing your data quality. Constraints table. So the idea is that you have a table that sort of lists different sort of business constraints. So first, let's just kind of walk through the SQL. We have a table of product data. Okay, so basically we have different product data. And we may have some rules regarding things that should be true about that product data that we may want to validate that data against. So we track these sort of truths in a business constraints table. Okay, so the idea is that these are rules that are data that should be applied to our data that we can now use because it's in this other table to check our data. So in this case, we're going to inject some prices for our products here. So we inject some products there. Now this is one price that's potentially out of range. So you see this one's like has a price of 105. And then we insert some rules. So for our first rule, so basically our business constraints table has a key. So that means like what the rule is, and then potentially 2 values that can be used to sort of validate the rule, and then maybe a note with some sort of explanation of the rule. So the first rule we're injecting is a price range. So saying none of our products should be outside of the price range of 10 and 100. Okay, so that's the valid price range for our products. Okay, the second rule we have is days before sale. Okay, so the idea is that if the product has been on the shelf for more than 90 days, it should be on sale. Okay, So in that case, if it's been on the shelf for longer, then we have to then ask ourselves, why is it not on sale? Okay, so these are some of the business rules that we have, okay, that are in there, and then we're going to go validate those rules. So in this first query we do is we were selecting our products, and then we're just checking, hey, give us back any products that are outside of our price range. Okay, so that we identify products that may need some sort of remediation, some fixing. Then we do the same thing here, where we're going to check, hey, let's take a look at the number of days between the date was posted on the shelf and our, so basically the current date and the date added. And if that exceeds, okay, the number from our business constraints, the 90 days, then, and on sale is false, so that means it's over 90 days, but it's also not on sale, well, we want to see that because those are going to be products we want to revisit. Okay, but see, basically by using this business constraints table, I could test this and other tables against rules that I want to make sure I apply. So it's one way to kind of help sort of not validation of like your typical types of validation, like null checking, whatnot, but checking things that are more about your business specific rules than necessarily just natural sort of data quality issues. So in this case, let's run the query. Okay, hit run. Okay, oh, I forgot to set the context. So let me just cancel that. Let's set the context to our January folder. Select, and let's run that again. Boop. Okay, and it's running, so it's going to be creating our tables. Again, you can always find the code for all of this in the link in the video description, along with in a repository that has a lot of other really cool resources as far as snippets to help you with using like Apache Arrow in Python and exercises so you can try out some of the stuff on your laptop. Lots of really great resources in that repository. But with that, looks like it's wrapping up. So let's go here. We create the table. Okay. Then we created another table. Okay, that's our table for business constraints. Okay, we injected our product data. We injected our first constraint and our second constraint. Okay, and then we go check to see, hey, who is outside of the range, and we get that product C is outside of our price range. Awesome. And then we can go then address that or fix it. And then we have here that product A and product C are both been on the shelf for longer than 90 days, but they are for some reason not on sale. Okay, so now we've been able to check these things that are part of our business rules to kind of help monitor sort of business activity better. So I'll see you guys in the next one. Have a great one, and ciao. Now, hopefully you guys enjoyed these demonstrations of showing you sort of working with Dremio and how the different ways you can do so. Again, the best way to kind of see this firsthand is to get hands-on with it. We have plenty of videos over there at the Dremio.com YouTube channel showing you how to do different things like connect to Superset, connect to Tableau, pull data in Dremio into a notebook, etc. But first thing you need to do is build your lakehouse. So if you want to build your prototype lakehouse to start getting hands-on with this, scan the QR code there on the left to get started building a lakehouse on your laptop that you can try out and experiment with. And when you're ready to get into to build that production lakehouse to get all those business outcomes that we've discussed in this presentation, scan that QR code on the right and we'll go there. But again, thank you for listening to this presentation. My name is Alex Merced. I'm a developer advocate here at Dremio. And now our next step is to do some Q&A. So I'll see you there.
Hey everybody, welcome back. So again, now it's Q&A time. So you can put any questions that you have about anything throughout the presentation in the Q&A box. So I'll be keeping an eye on the Q&A box. We do have one question already ready to go, so I'll be answering that question in just a moment. But just some quick housekeeping. Again, you can find full versions of like that DBT video and whatnot over there on our YouTube channel, youtube.com/Dremio. This presentation will be posted, the HD recording, the slides, the whole McGill will be posted over there at dremio.com/gnarly-data-waves within 24 to 48 hours. You should be getting an email with a lot of this information post this presentation. But just want to make sure you guys are all aware of that. But okay, our first question from Kyle Broadbeck. Thank you. One more question. How does this compare in concept to Microsoft Fabric that tries to achieve the same unified approach with one leg? The bottom line is basically we're not all going to have our data in one place. But basically, everyone's kind of starting to move in that sort of unified direction. Dremio's been doing this for a long time, having this sort of unified lake approach, where basically you can connect all these data sources. But some of the biggest high level differences is that one, Dremio's will be multi-cloud, so Dremio makes it really easy to work across multiple clouds and on-prem environments. So when you have environments in different clouds or cloud and on-prem environments, and you need to unite them, Dremio is going to be a really effective solution. Two, Dremio's generally very built around Apache Iceberg. While right now the Fabric One Lake is more built around Delta Lake. Dremio supports reading Delta Lake tables, so you can have Delta Lake as part of your Dremio Lakehouse as well. But again, it depends on like if you're definitely more leaning in the Iceberg direction, Dremio is going to provide you a much more robust solution at the moment. As far as an Iceberg Lake. Now, other things again to consider is again um, the agnostic, again, the idea that's independent of your cloud provider. So that way, again, one day you decide to switch cloud providers, Dremio goes where you go, which is nice. And again, always keeps everything in open formats, tries to do everything in standard ways. So again, using that messy catalog allows you to use your catalog and take your catalog across the different tools, which is nice. So that way, that semantic layer, that all that all that data that you curate is not just in Dremio, but again, that is all accessible in Spark, it's accessible in Blink. That becomes a much more sort of open environment when you're using a Dremio Lakehouse. And then plus just sort of so that would sort of be the main distinctions, the top high level distinctions. I mean, there's also differences in functionality, but again, there's places where they can play together very well because Dremio can connect to Azure data sources. So you can have a one lake data lake and use the one lake services, but still have Dremio connect and be able to see all your data sources that you're curating on one lake because it can connect to your ADLS storage and so forth. So they can actually share and work together. So oftentimes things are better together. Uh, okay, next question is does Dremio supports other programming languages except SQL? Now, at the moment, the SQL query engine natively accepts SQL commands. So essentially, as far as like what does it natively understand? SQL. But you do have a REST API. So theoretically, you can use any programming language to automate what you're sending over to Dremio through REST API calls. So you would eventually, inevitably send an SQL command to Dremio, but again, the scripts that automate it, uh, abstractions that you build around it, can be done in any language. In the future, that might expand a bit, but one day at a time. But right now, again, Dremio has a REST API that allows you to pretty much interact with the Dremio, your Dremio cluster from any language because it's just basic HTTP calls. On top of that, you also have a JDBC ODBC interface, which can generally be used in any language, and a Apache Arrow Lite interface that can be used in any language. But generally, the actual directions you're going to send over to the engine will always inevitably be SQL. But again, the scripts that you use to automate and maybe curate the data ahead of time before generating that SQL can be done in any language. For example, in Python, there's a library that I made called Dremio Simple Query that makes just working with the Apache Arrow Lite endpoint much, much easier, whereas just being able to connect, send the SQL pretty easily. But yeah, so that's the kind of state of things. Again, there may be cool advancements in that area in the future, but we'll have to see what the future holds in time. Cool, cool. Okay, so again, just to summarize, again, Dremio, the biggest thing about Dremio versus any sort of like cloud vendor specific lakehouse solution is that it is cloud vendor agnostic. So it can play well with your particular cloud vendor's tools, but it also doesn't lock you into those tools either. So it gives you that. And then also when you have multiple, because some people might have AWS and Azure, some people might have AWS, Azure, and on-prem and Hadoop. Dremio is going to allow you to kind of connect all that together and basically deliver all your data from one place with all those cool tools that we talked about throughout this video. Okay. Again, put any questions you have in the Q&A box, and I will be here to answer the question. I'll give it a few more moments for any more remaining questions. Okay, and again, next week we will be doing a getting started seminar. Okay, so if you haven't gotten started with Dremio and you want to see an additional demo, so basically next week's demo is actually going to be kind of neat. What I'll be doing is I'll be taking the seat of like a data engineer fulfilling data requests. I'm going to have like a Trello board where I'll be sort of taking a look at different data requests that have been coming in and working my way through them using the Dremio platform to kind of see how it makes the data engineer and the data analyst life a lot easier through many of the things that we've solved today. But we'll be doing that as well next Tuesday's episode of Gnarly Data Waves. And we have so many other really cool episodes of Gnarly Data Waves coming up. Also, just a lot of cool new content on the Dremio YouTube channel. Generally, we've been putting out a video almost every day, whether there are little educational hits or demonstration bits. So if you haven't been checking out the Dremio YouTube channel and the Dremio blog, there's a lot of new content that's come out over the last few weeks on both. that can be very, very valuable. I highly recommend taking a look at, and not just for evaluating whether you want to use Dremio, but just for a better understanding of the Lakehouse space and cool things you can do when you're taking advantage of Lakehouse. So with that, again, my name is Alex Merced. I see no further questions. So in that case, I will see you all next week for another episode of Gnarly Data Waves. Again, do make sure to subscribe to Gnarly Data Waves on iTunes or Spotify, so that way you never miss an episode. And subscribe to the Dremio YouTube channel at youtube.com/Dremio. But otherwise, I'll see you next week. Have a great one.